रीसेट हुआ है जस्ट आज ही, क्यों बता रहा हूँ बट ठीक है। There's an integer array sorted in ascending order with distinct values. Prior to being passed to this function, nums is possibly rotated at an unknown pivot index k. कहीं से तो रोटेट कर देगा। फॉर एग्जांपल ये अपनी आगे लिस्ट थी, इसको कहीं से 3 से रोटेट कर दिया तो ये बन गई। तो हमको क्या दिया, गिविंग द array nums after the possible rotation with an integer target. Return index of target if it is in nums or -1 if it is not in nums. बाइनरी सर्च में करना है ऑफकोर्स। सॉर्टेड है, मतलब पूरी सॉर्टेड नहीं है, टू हुई है। अभी क्या अप्रोच लगाएं कि मैं जीरो को ढूंढ पाऊँ इसमें। पहले तो स्प्लिट कहाँ से वो फाइंड आउट कर लें। Once I find out that, तो जो जीरो है नंबर, मुझे दोनों के स्टार्टिंग पॉइंट मिल जाएंगे। देखो दो स्प्लिट ही रहेंगे हमेशा, लेफ्ट और राइट वाला स्प्लिट है ना। तो लेफ्ट वाले स्प्लिट में या राइट वाले स्प्लिट में ये आइडेंटिफाई हो जाएगा, और फिर उसमें बाइनरी सर्च लगा देना। ठीक है, मैक्सिमम ऑफ 2 ऑफ लॉगिंग टाइम रहेगा। अभी इंटरव्यूअर को बताने के लिए कैसे बताना होगा। मुझे स्टार्ट विद ब्रूट फोर्स। ये कंडीशन अगर इग्नोर करें, सर्च करना है जीरो, सीधे लीनियर सर्च लगाऊंगा ओ ऑफ एन में एंड ओ ऑफ वन स्पेस में हो जाएगा। तो ऑप्टिमाइज करना है, सॉर्टेड ऑर्डर में दिया, मतलब काइंड ऑफ सॉर्टेड है, तो दो पार्ट में कर लेंगे। पहले तो कहाँ से ब्रोकन है वो पता लगा लेंगे, फिर लेफ्ट में ढूंढना है राइट में ढूंढना है, ये अपन पता लगा लेंगे। पहले एक लो ले लेंगे, हाई ले लेंगे। हाई will be this minus 1। थोड़ा सा साइज बड़ा करते हैं, अब मैं क्या करूँगा, वाइल को एक इंडेक्स रखेंगे स्प्लिट, करेंटली 0 रखते हैं। तो लो, पहले तो एक बार ड्राई रन करते हैं। लो इज हियर, हाई इज हियर। Since high is less than low, नहीं फिर मिड पॉइंट है पॉइंट 7 7 is greater than low that means ये लेफ्ट में आएगा तो मेरा लो हो जाएगा 0 पे let's take a list 6 7 8 0 1 2 3 4 5 for the low is here high is here and mid is here mid मुझे क्या करना है फर्स्ट एलिमेंट ऑन द राइट विच इज स्मॉलर देन उसका प्रीवियस want to find index of first number smaller than its previous. मुझे लेफ्ट मोस्ट नंबर निकालना है smaller than 4 smaller than 4 क्या करूँगा I'll take this 6 0 1 2 3 4 ये है मेरा array Low is here, high is here, mid is here. मिड वाला एलिमेंट इज स्मॉलर, तो मेरा जो पिवट होगा वो तो यहाँ होगा, तो इससे लेफ्ट में ही होगा, तो एच को मैं मिड पे ही रखूँगा। मिड आ गया, तो मिड जो है तो यहाँ होगा, जीरो मिड इधर हो गया, नॉट लेस देन, तो प्लस वन पे डालना है। Is less than, इसको मिड के बराबर करते हैं। तो अभी जो मेरा लो पे होगा, लो हैज इंडेक्स ऑफ फर्स्ट एलिमेंट स्मॉलर देन if this target जैसे मेरे को 3 फाइंड करना है। Oops. What is I भाई? I तो यूज कर दिया भाई। मैं एक एल लूंगा, एक आर लूंगा और एक टारगेट लूंगा। इसको चार्जिंग करूंगा। For this example, 4, 5, 6, 7, 0, 1, 2. Okay, low is here, high is here. 1, 2, 3, 4, 5, 6. 6 plus 0, 6 by 2 is 3. Mid is here. What am I doing? Number of num at mid is less than num at 0? No. So low is equals to mid plus 1 कर रहा हूँ। No, जबकि मैंने low equals to mid करना चाहिए। Let me fix this. How do I find index of smallest element? Mid is greater than high. Definitely यहाँ तो नहीं है. It is greater than or equal to 9, then definitely write with a 9. अगर बड़ा है लास्ट वर्ड से उस Let's look at my previous submissions. 2020 में सॉल्व किया था बहुत गंदा सॉल्यूशन हुआ Bro, solution.
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem search a given element in a sorted and rotated array. Now this question states that you'll be given an integer array, correct? And this is a sorted array, but it is rotated. Like if you carefully observe 0, 1, 2, after that it should have been 4, 5, 6, 7, but it's rotated. Like 4, 5, 6, 7, which give the target and first algorithm that comes to your mind is definitely binary search. But obviously the array is not completely sorted. So you have to make some observations in order to implement binary search in a rotated sorted array. So how will you do that? Okay, let me tell you a very simple stuff. Imagine you're standing over here. Okay, now if I ask you, is the left half sorted? Ask a very simple question. Is the left half sorted? You'll be like, yes, it is. And how did you know that? Because this four is smaller than this six. And if that's the case, we can definitely say that the left half is sorted. If left half is sorted, can we say this target appears on this left half or not? We can. Correct? We can. So this is the tweak that we're going to do in the binary search, right? Now imagine you're standing over here on the 0, and I ask you, is this left half sorted? You'll be like, no, it isn't, because 4 is not lesser than 0. So the left half is not sorted. Now you can again do the binary search on the right half saying, does this target 0 appear on the right half or not? So we actually know if we are standing somewhere, either the left half or the right half, either of them has to be sorted, correct? And we're going to use that property to implicate binary search over here. If you haven't understood, not an issue. You can go through the dry run, and once you go through the dry run, it will be much more clear in your head. Okay, so let's take the target equal to 0, and let's start the binary search. You know the binary search is on the complete array. So let's take low over here. Let's take high over here, correct? So low is initially at the 0th index, high is initially at the 6th index. So if you try to figure out the middle index, I can definitely say the middle index is over here. That is at the 3rd index, 0 plus 6 by 2. So if you're standing at the 3rd index, what's the first step of binary search? Binary search checks if this 7, I repeat, if this 7 is equivalent to the 0. So binary search says no, 0 is not appearing on the middle index. So now your task is to look if the 0 appears on the left half or on the right half. That's your task. Now in order
The left half sorted and this 0 lies between them. तो मैं उसमें चला दूंगा. Left half is not sorted.
to do that, let's understand which of the halves is sorted. So can I say that the left half is actually sorted? Why can you say that? Because this 4 is lesser than this 7. So if it is, and since I know it's a sorted array, I can definitely say that this entire left half is sorted. Now if this is sorted, what I can say is, let's check if this target 0 appears over there. And it's a very simple check. If this target 0 is greater than equal to 4 and lesser than equal to 7, I could have said that this target 0 appears somewhere in between them, but it is not the case. But it is not the case. And if that's not the case, I can simply eliminate this left half saying my target 0 can never appear over here. And what I will do is I'll take this low and I will move it ahead to low equal to mid plus 1, similar to what I do in binary search, because it doesn't appear on the left half. And I'll search my 0 on the remaining portion of the array. So let's do that. So once your left portion is eliminated, the low will be standing at the 4th index, the high will be standing at the 6th index. So your middle will be currently at the 5th index, correct? Binary search first tool. Check if this guy is equivalent to your target. And I see that no, that is not. And if that is not, what you will do is you'll try to figure out if this 0 exists on the left half or on the right. And in order to do that, please check, yes, I repeat, please check if the left half is sorted or not. So let's check if the left half is sorted. So if this 0 is lesser than equal to this one, can I say the entire left half is sorted actually? And yes, that is the case. The left half is sorted. And if it is sorted, can I say our target 0, if it lies on the left half, should be greater than equal to the leftmost element? That's 0. And should be lesser than equal to the rightmost element? That's 1. And it is. And since it is the case, can I say my 0 lies over here, because I've already compared it with mid. So I'm very much sure it doesn't lies on the right half anymore. Yes, I'm very much sure it doesn't lies on the right half and it lies on the left half. So what I will do is I will come over here to the same index where low is, and it will eliminate the right half. So let's eliminate this right half and let's try to do the binary search for the remaining portion of the array. So once the right half is eliminated, the low is pointing to the 4th index, the high is pointing to the 4th index. So can I say the middle is also pointing to the 4th index? Yes, I can. Yes, I can. And if I can, the first step of binary search is to compare the middle element with the target. And I can see that, okay, yes, I got my 0. Yes, I got my 0. And the moment I get my 0, can I say this is where my target 0 appears, because there was a very important property. The sorted rotated array has only distinct elements. And since it has distinct elements, I know target 0 will only appear once. So can I return this middle? and the middle value is 4. So I can say I found my target 0 at the fourth index, and that's my answer. So by eliminating the left half, right half, I at the end ended up on my target 0th index, and that will be my answer. So let's take this target 3, which doesn't appears in this array to the at the third index. 4 is lesser than equal to pair if 3 exists in the left half. And if it doesn't exist, then the left half will extremely get eliminated, and my low will move over here. So just move the low to the fourth index, and I will. So again, just check if the middle guy 1 is equivalent to 3, and that's not the case. And if that's not the case, just see if the left portion is sorted. And I see that the left portion is sorted because 0 is less than greater than equal to 0 appears on this left half. Take the low and point it to mid to the sixth index. So let's try to check if this 2 is simple check. Should be greater than equal to its low, which is 2. Should be lesser than equal to its high, which is 2, and that's not the case. And if that's not the case, you eliminate this portion, and you take this low and place it one above high. One above high. So the low will be pointing somewhere to an imaginary index 7 because the low will move a 1 ahead of high. That's 1 of mid plus 1. So once you do that, you see one thing, that your low has crossed high, and you've actually eliminated every portion of the array. So if target simply portion from IIT standpoint, that just simply return a mid. Because not if your now what if your left side was not sorted? Then you cannot compare on the left side, right? That means the right side is sorted, and if the right side is sorted, do the similar thing. Just see if the target appears on the right half. And if it appears, it should be greater than A of mid and should be lesser than A of high. That means it appears on the right half. And if it appears on the right half, that means eliminate the entire explanation and the intuition.
Bro, such a nice question. Median of two sorted arrays. Given two sorted arrays, number 1 and number 2 of size m and n. Return the median of the two sorted arrays. 1, 3 or 2 here, and median will be 2. थोड़े बड़े बड़े इनपुट दो ना भाई, छोटे छोटे दे दिए. Two sorted arrays. Let's take two sorted arrays. इसको पूछता हूँ मैं सही नहीं, मेरे को क्वेश्चन क्लियर वो नहीं मिलने वाला है. ठीक है, पहले I'll take 1, 4, 7, 9, and the second one 2, second one will be 1, 3, 5, 6, 1, 3, 5 होंगे. ठीक है, और median will be 1, 1, 3, 4, 5, 7, 9. The median will be 4. मीडियम नाम है, उसके लेफ्ट में टोटल एलिमेंट्स m प्लस n है, तो m प्लस n बाय 2 एलिमेंट्स लेफ्ट में होंगे, m प्लस n बाय 2 एलिमेंट्स राइट में होंगे. देखो अगर इवन होता है तो इन दोनों का 2 होगा. What will be the brute force approach? Basically, I'm thinking create another list. Merge that in O of m plus n time and then go to the middle element. That will be O of m plus n. I need better time than that. So for every element I have to identify देखो इसका minimum और maximum देख लो minimum is 1 search space will be between 1 to 9 ठीक है अभी 1 to 9 है मेरे पास 1 से छोटे या बराबर कितने एलिमेंट्स हैं 2 2 से छोटे या बराबर 2 3 से छोटे या बराबर 3 4 से छोटे या बराबर 4 5 से छोटे या बराबर 5 एलिमेंट्स 6 से छोटे या बराबर 5 एलिमेंट्स 7 से छोटे या बराबर 6 8 से छोटे या बराबर 6 एलिमेंट्स 9 से छोटे या बराबर 7 एलिमेंट्स छोटे या बराबर एलिमेंट्स ठीक है 7 है 7 बाय 2 3 9 है ना 9 बाय 2 इज 4 तो पहला कौन सा नंबर है जिसके 4 छोटे बराबर 4 एलिमेंट्स हैं ये अगर हम एक एग्जांपल ले लें इसमें दोनों में इवन एलिमेंट्स हैं सारे तीन होगा इसका आंसर सेम अप्रोच से जाएंगे छोटे बराबर 2 छोटे बराबर 2 छोटे बराबर 3 छोटे बराबर 4 छोटे बराबर 4 4 जिसे विचार करें 3 से बड़ा कौन सा है यानी ये क्या निकलना था, पूरे सेल्फ स्पेस में से छोटे बराबर तक के एलिमेंट्स हैं, दो एलिमेंट्स थे, ये से छोटे बराबर चार एलिमेंट्स थे, टोटल एलिमेंट सात थे, सबसे पहला जो तीन से बड़ा हो, रीजन होगा तो तीन से बराबर straight to it. डबल इंटीजर है ना, तो मेरे पास सर्च स्पेस रेडी हो गया। मुझे निकालना है फाइव से छोटे या बराबर कितने एलिमेंट्स हैं। इस नीड एलिमेंट को First I'm assuming that m plus n is always odd, तो उस केस में m plus n निकल के आया 7, 7/2 3 निकल के आया। तो ये वाला पता लगाना है। Find first number. Less than equal to greater than 2. Equal to 100. मुझे क्या फाइंड आउट करना है? नम्स वन में कितने नंबर्स हैं विच आर स्मॉलर देन और इक्वल टू नम स्मॉलर देन इक्वल टू नम से I will go question this one is question एक टेस्ट केस तो पास होना चाहिए अवेलेबल है। ये वो वाला केस हो गया जब ऑड है। In case the total is even. Do I totally use AI to do this? This is not done.
Okay, so we will be continuing with our binary search playlist. Now, this is a part of the Strivers A to Z DSA course. In case you haven't checked it out yet, there's a link in the description. Make sure you check it out. So before starting, if you welcome back to the channel, I hope you guys are doing extremely well. So the problem that we're going to solve today is finding out the median of two sorted arrays. Now this word is very important, sorted, because that is what will help us to solve this problem. Now you can be given two arrays of equal size. You can also be given two arrays of different size. Like in this example, you can see this array is of size 6 and it is sorted. This array is of size 4 and it is sorted. Now what you have to do is you have to find the median of these two sorted arrays. So what you have to do is you have to take both of the sorted arrays and you have to combine them. So if I combine them, what I get is 1, 2, 3, 3, 4, 6, 7, 10, 12, 15. What is the total number of elements? The total number of elements in this case is 10. Why? Because n1 was 6, n2 was 4. So the total number of elements is 10, right? So if I try to find out the median, can I find a median of 10 elements? I cannot. Why? Because if I stand over at 4, there are 4 elements on the left, there are 5 elements on the right. If I stand at 6, there are 5 elements on the left, 4 elements on the right. So there is no specific median, because median means on the left and on the right there must be equal number of elements. Now this is not, in this case, this is like 5 and 4. They're not equal. So can I say the median will be somewhere between 4 and 6, because if I take somewhere between 4 and 6, on the left there are 5, on the right there are 5, which is equal. So I can say that the median is somewhere between 4 and 6. So it's like the middle of 4 and 6. So 4 plus 6 by 2. 5 is the median in this case. Now over here the point to notice was the total number of elements was even. That is why it did not have a specific median. But what if I take this example? There's like 3 elements, there's like 2 elements. So what is the total number of elements? Can I say that the total number of elements in this case is 5? I can. So if I try to combine them in this time, what will I get? If I try to combine them, I'll get 1, 2, 3, 3, 4. If I ask you what is the median, can I say this is the median? I can. Why? Because there's like 2 elements on the left, there's like 2 elements on the right. Thereby the median is pretty simple, the midpoint. So in case of the total number of elements being odd, it's very simple. In case the total number of elements is even, I have to consider 2 elements and I have to take the middle of it. Got it? Now this is what we have to find. We have to find the median of 2 sorted arrays. So what is the first solution that you can think of? The extreme brute force that comes to my mind is, okay, 2 sorted arrays. Can I merge them into a third sorted array? And if I merge them, then I know I can solve it afterwards. And the point to notice over here is both of them are sorted arrays. And you know how to merge 2 sorted arrays into one. We have done that in merge short, isn't it? So what I'll do is I'll stand at 1 and I'll stand at 2. And I'll try to take another third array and I'll try to put it over there. Will I take 1 or will I take 2? I'll take 1 because I'm trying to form a sorted array, so I'll take 1. And I'll move. Will I take 2 or will I take 3? I'll take 2 and I'll move. Will I take 3 or 3? I can take any one. I'll take 3 and move. Will I take 3 and 4? I'll take 3 and I'll move. Will I take 6 and 4? I'll take 4 and I'll move. Will I take 6 or 7? I'll take 6 and I'll move. Will I take 7 or 15? I'll take 7. I'll move. Will I take 10? Yes. Will I take 12? Yes. Will I take... After this, there's nothing. So whatever is left on the right, I'll just take it. So we have put 2 sorted arrays into the third one. Now what is the next step? The next step is to find out the median. Can I say if the total number of elements is even? I need to find 2 median elements. One is 4 and the other one is 6. And I need to basically add them and divide by 2 to get our median, right? And you know how to find it. The index is 0, 1, 2, 3, 4, 5. You need the 4th index and the 5th index. 5th index is nothing but 10 by 2 and the 4th index is nothing by 10 by 2 minus 1. So you get both the indexes and then you can do your job. I'll write that in code, but before that, let's look at the other example. In the other example, basically add them and just I've put two sorted arrays into the third one. Now what is the next step? The next step is to find out the median. Can I say if the total number of elements is even, I need to find two median elements. One is 4 and the other one is 6. And I need to basically add them and divide by 2 to get our median, right? And you know how to find it. The index is 0, 1, 2, 3, 4, 5. You need the fourth index and the fifth index. Fifth index is nothing but 10 by 2 and the fourth index is nothing by 10 by 2 minus 1. So you get both the indexes and then you can do your job. I'll write that in code, but before that, let's look at the other example. In the other example, when you try to merge them, you'll get something as 1, 2, 3, 3, 4, and over here, the total number of elements is odd. And which index do you require? You straight away require this one, which is the second index. Can I straight away write 5 by 2, and that will be the second index, and that will be my only median? I can, right? So this is how the brute force will be. So let's quickly write down. So let's quickly write down the pseudocode. So what I've done is I've taken an array 3, which is an empty array. I've taken index I, which points to the first element of array of 2i to 1. Now what? In that
One
was
thing we
if
can do
array.
is, if we already know how many elements it has, so currently it has 10 elements. So while I'm looping over the individual and making the third array, if my array has 5 elements, I'll stop then and there. So थोड़ा सा बढ़ते हैं.
Array of 1
It will
of
still be of m plus n by 2. So n1 plus n2 by 2. Order of n1 plus n2 by 2.
I is lesser than array of 2 of j. In that case, I'll ask array 3 to add array of 1
Is anyone watching? No, I'm bored. Okay, so that's
of I and do a plus plus. Basically, after you add, you move forward because we're done with you. Else, I will say array 3
okay.
because I say if j is right, what I know if n is e or rather odd, I know the answer will be very simple. Array 3 of n by, because in that case it's exactly the middle. If you remember for if I have to write, it's array 3 n by 2, because if you remember for 10 you have to pick by 2. This will be only minute differences and typecasting over here because the answer will be in double, and if you do not typecast, these are integers, you might end up getting incorrect answers. So if you try to submit this, you'll get a partially accepted. Why? Because it's taking a lot of time. The total time taken over here will be, you're going through every element in both the arrays and you're putting them into a third array. So since you're going through every element, that's n1 plus n2 because that is the total number of elements. You're using a third array to store all the elements, so that's a big of n1 plus n2. And this is giving you a time limit exceeded. And can we do better? The next better solution will be to optimize the space, and after that we'll try to work on this time limit exceeded. But as of now, can we optimize the space, like get rid of this third array? That is what we'll look forward. So the brute force solution, we were using an extra space. Why was that? Because I was using an array 3 where I was storing all the elements. But if I just think logically, where need all the elements? The answer to that is, if I can somehow just get 4 and 6 for this example, and then just divide them by 2, that's done.
No,
I don't need all the elements. Why am I storing all the elements? I just need 4 and 6. In this particular example, I just need 3. I don't need all the elements. So let's focus on picking up 4 and 6 only, or let's focus on picking up 3 only. So when you're doing the algorithm, if you remember, we checked for n's value at the end. If it was odd, we did the computation. If it was even, we did the computation at the end. But before that, we merged them to get index 1 element. At the fifth index, add the index 2 element. And if it is even, I'm adding them up and dividing it by 2. So let's call index 1 as 4 because I need the fourth index element, and index 2 as 5. I need the fifth index element, which is called as element 1 and element 2. And what is these values? If you just do total by 2, you'll get index 2. And if you just subtract it by 1, you'll get the index 4. So it's basically n by 2 and n by 2 minus 1. And this is index 1 and this is index 2. In this case, if you divide by 2, you will get index. So sum and divide by 2. In case the element is odd, I will have index 1 and element 1, but I'll discard it, and I'll just take element 2. Process try to find the fifth index element. That is index 1 and index 2. So we will not be merging it. How did we merge? We started at 1 and we started at 2. Hypothetically think, which one will be your 0th index guy? 1 will be a 0th index guy, right? Let's move to 3. And that means the count moves to first. You're looking for your first index guy, and that's 2. Let's take 2. And now let's take it will be 3. Is looking for an index which you need. So which one will it be? 4 or 6? It says 4 because of the comparison. So I take 4 and I say got my element 1 because I was looking for the fourth index guy. So I got my element. And after that I'll move. Now the count will move to the fifth index because I'm looking for the fifth index guy. Again, it's happening hypothetically. You're not storing these elements. You're just not storing. You're just playing with the pointers. You just move the pointers. The count is at 5th, and he says 6 is the guy, and he stored the 6. Just store the 6. And then you move the count and you keep on doing your process. And if you figured out both the elements, the job is done. And the answer will be element 1 plus element 2 by, and that's it. In case n was odd, so let's quickly get back into the code editor because if I try to write down the code in the iPad, it's going to be super messy. And since we're just using increment operators and while loops, I think the C++, Java and all the versions will be similar, so you'll be understanding it. Doesn't matter which language you follow. So what I am doing is at first making sure I take n1, n2 and initialize I and j pointers and get the value of n. After that, we know the values of index 2 will be half of the total length and index 1 will be 1 before. Simple. And we're keeping the index tracker. This is the tracker. The count is the tracker, which is basically saying, okay, on array 3, this is the index that I'm looking for. Initially, you're looking for 0 things, right? So that's your index tracker. And we haven't figured out the elements, so that can be stored as -1. What I do is, I basically do the same loop, where I try to merge both of them. If for this index tracker count 0, this element is smaller, I go inside, and I know array of I is the element that will be present at my current index. And if the index tracker is equivalent to one of my index that I'm looking for, I say, hey, please assign yourself. If my index tracker is equivalent to the other index that I'm looking for, maybe assign yourself. So either of these conditions. And after that, count plus plus, because this index is done. Let's find out the next index, and I plus plus. So this is how this one will. A similar thing will happen for the else. What if we have taken B? In that case, the index tracker will just take the B and we move forward. Very straightforward, very simple. Again, this condition can be right after that. The same else, you just keep on. Conditions can probably have to both of them, and then these conditions will be executed. If it is a not, I just need the index 2. This will also extra space that we are using for storing the entire. I haven't reduced down the time complexity. What we have done is we've reduced the space. We're no more using the extra space that we are using for storing the entire array. We're just keeping the trackers, which tracks the element, because that is what we require. Got it? Okay, so we will be continuing with our binary search playlist. Now, this is a part of the Strivers A to Z DSA course. In case you haven't checked it out yet, there's a link in the description. Do the strategic linear search, and we'll try to do it even. So let's first combine them. I'll get 1, 2, 3, 3, 4. If I ask you what is the median, can I say this is the median? I can. Why? Because there's like 2 elements on the left. There's like 2 elements on the right. They have a 2. You get a valid symmetry. You can try out picking 4 elements. Right, it'll be 3, 4, 7, 10, 12. Is this a sorted array? From array 1, there are like 4 elements from. It be this itself only. It cannot be anything else. Correct? Left half. If we are able to do that, we can actually find out the median. How? Let's understand. Imagine if we try to draw a symmetrical line on that median. On the left, there are 5 elements. On the right, there are 5 elements. Notice this symmetry. Okay, next step. Out of these 5 elements, how many are coming from array 1? Can I say 1, 3, 4? So there are 3 elements from array 1. Agreed? And there are 2 elements from array 2, right? On the right, there are 3 elements. The rest 3 are on the right, and the rest 2 are on the right. So this is where we'll start our binary search. We will try to formulate the correct left half. We will try to formulate the correct left half. If we are able to do that, we can actually find out the median. How? Let's understand. Imagine you formulated the correct left and you formulated the correct right half in hypothetical scenario. Then the median will be 4 plus 6 by 2, isn't it? Right? So our task will be to figure out, okay, 3 elements from array 1 and 2 elements from array 2 will formulate the correct left half. Because one thing I'm very sure is the left half will be this itself only. Will be this itself only. It cannot be anything else. It cannot be anything else, right? How to do this? Let's understand. Let's do the strategic linear search, and we'll try to do it, build on it. So we're trying to build the left half, and we're trying to build the right. So imagine I say you from array 1, because we know we need 5 elements. What's the linear search? Like, where does it start? Maybe pick up 0 elements from array 1. I'll pick up no one from array 1. I'll pick up no one from array 1. If I pick up no one from array 1, what will happen? In that case, I'll have to pick up 4 elements from array 2, because how many do we need on the left? We need 5. So if I pick up no one from array 1, there are like 4 elements from the left. Array 2, I have to pick up every one of them. Even if I pick up every one of them, I cannot get 5 elements. Something I know for sure is, if I pick up 0 elements from array 1, it's not, like 0 elements is not possible. Like, fine. Can you pick up 1 element from array 1? He says, why not? So I pick up 1 element from array 1, which is 1, the first. How many do we need to pick up from array 2 then? We need to form 5. We need to pick up 4 more. So what I'll do is, I'll end up picking 2, 3, 6, 15. I'll end up picking 2, 3, 6, 15, right? What will be on the right? The remaining, very simple. 3, 4, 7, 10, 12. So what I've done is I've said pick up 1 from array 1. I've done this and pick up the remaining. So there were total 5. The remaining 4 got picked up from array. Now, can I say this is a valid configuration? I cannot. Why? Because if I try to sort them up, it'll be like 1, 2, 3, 6, 15. And the right will be 3, 4, 7, 10, 12. Is this a sorted array in any means? Even if you draw symmetry, this is not. Why? Because 15 is greater than 3. That cannot be a sorted array. That cannot be a sorted array. How do you recognize that? We'll come to that afterwards. So you come to that afterwards. But as of now, this cannot be a valid symmetry. Perfect. Let's go to the next. Next is pick up 2 elements. Okay, let's try to pick up 2 elements. It'll be like 1, 3 from this. Perfect. So how many are remaining? There were 5. We picked up 2. 3 more. Let's pick up the 3 more from the array 2. Picked up. That's the left portion. What will be the right portion? All the remaining elements. 4, 7, 10, 12, and 6. Oh, sorry, my bad. 15. Is this a valid configuration? It isn't. Why? 1, 2, 3, 3, 6, if I try to write them in a sorted order, and this will be 4, 7, 10, 12, 15. Again, possible. Perfect. So 2 is also not possible. What is it? The next job. The next job is maybe pick up 3, maybe pick up 3. So if I pick up 3, it will be 1, 3, 4. So if I pick up 3 from the array 1, if I pick up 3 from the array 1, how many from array 2? 2 more. Pick up 2 more. That's 2, 3. How many will be left from array 1? It'll be like 3 more left. So 7, 10, 12. And over here, it'll be 6, 50. Is this a valid symmetry? Let's look at this. If I try to write down them in the sorted order, it's like this. And this is like 6, 7, 10, 12, 50. And if you carefully notice, this is a valid symmetry because 4 is lesser than 6 and all of these are in the sorted order. So this is a valid symmetry. So what we figured out was, if I pick up exactly 3 elements from array 1 and the remaining from array 2, we get a valid symmetry. You can try out picking 4 elements as well. Try picking out 4 elements. So try picking out 4 elements, it'll be like 1, 3, 4, 7 from array 1. And the remaining will be just 1 more we require. So that's 2 from the array 2. And on the top, it will be 10, 12. And the remaining will be 3, 6, 15. Again, if you try to write them down, 1, 2, 3, 4, 7. This will be 3, 6, 10, 12, 15. You carefully observe. This is also not a valid symmetry because 7 is greater than 3. It should have been on this portion. This should have been here. It's not a valid symmetry. This is also not a valid symmetry. 4, like picking up 4 elements is not possible. So what did we notice? Picking up 0 not possible, picking up 1 not possible, picking up 2 not possible, picking up 3 possible, picking up 4 not possible, picking up 5 not possible. And that is the max you can pick up because, sorry, there's like 6. 6 is also not possible. So the only thing that is possible is 3. Something we observed is there will always be one valid symmetry where you definitely know 3 from here, 2 from here. There cannot be any other configurations. Got this? This is the first thing you have to understand. How many to pick? If you've understood this, then we'll move to the next. So till now we know one thing, that this problem is being solved on the basis of symmetry, where we decide 3 elements from the array 1 and 2 elements from array 2. This is what we have to get to. After that, we'll decide how to find out the median. That is our first step. But how do we figure out that it's a valid symmetry or not? Imagine you're picking up 4 elements from the array 1 and you're picking up the remaining 1 from array 2. So this is the left portion. This is the right portion. This is the array 1. If you carefully notice, this is the array 1 and this is the array 2. How do you determine that this is a valid symmetry or not? It's very simple. You know one thing for sure. This is array 1, so this will be sorted. This is array 2, so the second line will also be sorted. In order for this to be a valid symmetry, this 7 is on the left. This should be smaller than this 3. This 7 should be smaller than this 3, which is not the case. And this 2 should be smaller than this 10. This 2 should be smaller than this 10, which is not the case. That means the 7 should ideally would have been here. Ideally should have been here, right? That is why it is not, because 7 is greater than 3, so it cannot be on the left. We do not check for this, we do not check for this, no need, because it's from the same array. We just check cross. We just check cross. Now this is where we pick up 3 elements from the array 1 and 2 elements from the array 2. Now this is a valid symmetry. Why? Because this 3 is smaller than 7, which is a valid, and this 4 is smaller than 6, which is valid. Hence, all the elements on the left are smaller than all the elements on the right. Why? Because we already checked for, like, this is an array 1, so it is so. This is array 2, this is so. Just need to make sure that these cross guys are smaller. If that is, all the elements on the left are smaller than all the elements on the right. Hence symmetry. Hence symmetry. Got it? Next. What if we pick up 2 elements from the left? Sorry, 2 elements from the array 1 and 3 elements from the array 2. There's 3, there's 15. That's smaller. Perfect. Perfect. But the cross 6 is not smaller than 4. 6 is not smaller than 4. Hence, not possible. Not a valid symmetry. So we have also understood how do we figure out it's a valid symmetry or not a valid symmetry. So let's quickly do a recap. Till now we have done 2 points. The first one is the binary search will be on the basis of symmetry, where we determine how many from array 1 will be on the left, how many from array 2 will be on the right. And the second one, how do we determine if it's a valid or an invalid symmetry? We just compare the cross. If they are smaller, if the entire left is smaller than the entire right, it's a valid, otherwise not. But now the question arises, but how do we figure out the median? How do we figure out the median? Very simple, I'll tell you. And this is a valid symmetry. Over here we know these many elements from array 1, these many elements from array 2. How do we figure out the median? So let's probably call them as L1, L2, right 1, right. So L1 means left 1 from array 1, L2 means left 2 from array 2, R1 means right 1 from array 1, R2 means right 2 from array 2. Okay, how do we find out the median? Let's go back to the originals, sorted arrays. How do we figure out the median? We took the greatest of all on the left, we took the greatest of all on the left, and we took the smallest of all on the right, and we added them and divided by 2 to get our median. Same thing we do. We know one thing for sure. This array is sorted. So what will be, like, L1 will be the greatest over here. This array is also sorted. So 3 will be the greatest. So what will be the total greatest? The greatest on the left will be max of L1, L2. Quite simple. And what is the smallest on the right? Because that is what you need, the smallest on the right. The entire thing is sorted. So R1 is the smallest on the top, and R2 is the smallest on the array 2. So plus minimum of R1, R divided by 2. This is how you'll get the median. We'll come to odd afterwards, but as of now, please focus on understanding this particular even thing. Once you've done this, odd is going to be very simple. So till now we are following a symmetrical pattern to solve this problem, where we are figuring out that we need 5 elements on the left. How many from the array 1? How many from the array 2? So if we just focus on array 1, just on array 1. Why? Because if I can determine how many from array 1, the remaining, because total was 5. So if I pick up 3 from array 1, we just need 2 more from array 2. So from array 2, we'll know how much. So let's focus on array 1. How many from array 1 should be our focus? How many from array 2 will automatically be determined? How many from array 1? 0, not possible. 1, not possible. 2, not possible. 3, possible. Will I go and do a linear check? If we do, we fall back to the linear complexity. So we did not. But can I do a binary search? 4 not possible, 5 not possible, 6 not possible. Because that is the maximum elements I can take. Now, I can't see a binary search pattern. Because binary search is technically like not possible, not possible, 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 possible. I can't see a binary search pattern. But I'll tell you how to apply binary search. I know one thing. In the array 1, I can pick up no one, or I can pick all of them. In the array 1, I can pick up no one, or I can pick all of them. Now, how can I determine whether to go left and eliminate right by going left, or go right by eliminating left? That is what you have to figure out. Basically, if you're somewhere between 4, how do you eliminate the right half, saying 4 and beyond 4 is not possible, go and search on left? How do you do that is what you have to focus. For that, I'll come back to this example, and this example. Let's come back to that. So I'll write over here I'm picking up 4 elements from the left, over here 3, over here 2. So I know this is a possible answer. This is the left half, this is the right half. How do we determine this is the right half? Let's see. We're having 7, and that's greater than 3, hence not possible. So any case, this is known as L1, if you remember, L2, R1, R2. Any case, L1 is greater than R1. That means high will be eliminated. But this high will be eliminated. We cannot take the right. Not possible. We need to reduce the value of 4. 4 is not possible. Reduce the value of 4. This is possible. This is always possible. So we stop there. Stop there. What about if it's a smaller value? Let's look at this. In this case, the 6 is greater than this, which is the L2. Let me write it again. L1, L2, R1, R2. If L2 is greater than R1, in that case, the left portion will be eliminated, because if 2 is not possible, we cannot do for small elements. So these will be the conditions for binary search. This is how you determine whether to reduce 4 or whether to increase 2. These will be the conditions. Quite simple. Just ready observations and we're done. So I've said you about the thought process. Now what I'll do is I'll do a dry run by taking a couple of sorted arrays so that the thought process gets into your head, and after that we'll move on to the code. So the first question that I'll ask you is, in the example that we were taking till now, we are doing a binary search on an array of size 6, right? In order to determine how many elements will be fitting the symmetry. And we figured out that 3 elements were fitting the symmetry. And we are doing a binary search on a 6 length array. What will be the time complexity then? The logarithmic of 6 size, because you're doing a binary search on a 6 length array. So will it be better if I do a binary search on the smaller array? Because the search space is just 4 elements over here. So the time complexity will be logarithmic of 4. So ideally, I should never do a binary search to determine how many from the longer array. Rather, I should do a binary search to determine how many from the shorter array. If I do that, time complexity will be lesser. So I know one thing for sure is I need to do a binary search on the shorter version of the array. Now, if I try to combine them, we'll have 1, 2, 3, 4, which is from here, and we'll have 7, that is 1 element from the array 1. And at the end, 7 and 9 is what we will take, right? This is how it looks like. So we know that we have to do a binary search on how many elements we need from the smaller array. So in this case, I can say maybe I'll not pick up anything, and that will become my no. And what will be the value of high? Can I say my high will be the maximum that I can pick up from that array 1, which is n1 in this case, and that's basically 4, because 4 is the maximum number of elements that I can pick up from this particular array, right? Let's try to do a binary search. First time when I try to do a binary search, the mid 1, why am I calling it as mid 1? Because from array 1, right? So I'm saying pick up 2 elements from array 1. So I'm saying pick up 2 elements from array 1, which is basically over here, mid 1. Okay. So I'm picking up 2 elements from array 1. How many will I pick up from the array 2? In total, I need 5. 5 minus 2 will be 3. So I'll pick up 3 from array 1. 3 from array 2 rather. 3 from array 2. So it'll be pointing to index 3. Perfect. So if I try to segregate them, can I say 2 from array 1, which is basically 7 and 12, and 3 from array 2, which is basically 1, 2, 3. And can I say from the right, it'll be 14, 15. Point to observe is mid 1, index is pointing to 14, and 4, 9, 11, and mid 2 index is pointing to this. And if you remember, this was called as L1, L2, R1, R2. Is this a valid symmetry? No, this is not a valid symmetry. How did you figure that out? Because L1 is greater than R2. And let's quickly go and check out the condition. L1 greater than R2. The high has to reduce, because this is not possible, this is not possible. High has to reduce. So what will you do? You will go back and you will say this is not possible. So the entire right half is not possible. Hence, you trim off the 2 to 4 section and you will be over here. Perfect. This is what you'll do. I'll quickly erase this off so that we have better clarity. Perfect. Done. So starting at 0 to 1. Anything from 2 to 4 is gone now. What is the mid? This time the mid will be pointing to 0. So I'm saying I'm not going to pick up anything. The mid one is pointing to 0. What will be mid 2? Mid 2 will say I'll pick up 5 elements from you. So point to observe again. Mid 1 is at 0. And where is mid 2? Over here. That's 5. We'll try to segregate. On the left of this, there is no one. There's no one. Remember this, there's no one. There's no one from array 1. And 0, 1, 2, 3, 4, 9. Is it? No, sorry, my bad. 1, 2, 3, 4, 9 from array 2. And on the right, 7, 12, 14, 15, and over here, 11. So again, if I have to write down the indexes, this is mid 1, this is mid 2, and this is R1, R2, L2. You don't have an L1. Remember, if you don't have an L1, since this is your left portion, you always try to take a smaller values because it's not there. And you want to compare with a smaller, so just take a smaller value. If there is no one on the left, you just take a smaller value. It doesn't matter. Just take a smaller value, absolute value, so that the comparison is true. Okay. Int main, lesser than 11. True, true. 9 lesser than 7? No, not true, not true, not possible. So by taking 0 elements from array 1, it's not possible. Which is this case? Let's write down this case. L2 is greater than R1 is the case. Let's check out. L2 greater than R1. So you eliminate. Yes, you eliminate. And you say 0 is not possible. Eliminate this half. So you eliminate this. And the low now points to this. Please omit this again. Amazing. Perfect. What's the next thing? Okay, before that, let's quickly erase this. What's the next thing? We need to pick up one element. So the mid will also be there. So your mid goes and this. Will be mid 2. So if it is 1, this will be 4. So mid will be here. Perfect. Let's try to again segregate. So what I'll do is I'll do a segregation. When I do a segregation, it will be 7 on the left and 1, 2, 3, 4 on the left. And let's write the 7 properly. And over here it will be 12, 14, 15, and 9 and 11. So what you're basically doing is from mid 1 you're taking everyone on the right, from mid 2 you're taking everything, and on this. Simple. So can I say this will be mid 1, this will be mid 2, and this will be L1, L2, R1, R2. And if you carefully observe, this is smaller and this is smaller. Valid configuration. One element that you have to take. What will be your answer? Can I say L1 will be array 1 of mid 1 minus 1? That's what L1 is. L2 will be array 2 of mid 2 minus 1. Can I say this? I can. What will be R1? R1 will be array 1 of mid 1. And what will be R2? R2 will be array 2 of mid 2. Because mid 1 is pointing at mid 2 and the previous elements are there. In case there doesn't exist a previous element, or in case this doesn't exist, you try to take these values as intervene because they do not exist. And if on the right they do not exist, because you always check for smaller, greater, like in this order. You always check for this order. So you'll always take this as intermax if they do not exist. If they do not exist. And what will be that case? When you take all the elements, in that case there will be no right. That you take intermax. On the left, if there is nothing, you take intermax. Got it? So that's it. I have L1, L2, everything. You know the formula. You know the formula. What is the formula? The formula is max of L1, L2 plus min of R1, R2 divided by 2.0. This is only valid if the total number of elements is even. What if it is odd? Let's now jump into that. I might be thinking, what about odd elements? What I've done is I've taken an array where we have 2 and 3, so the total number of elements is 5, which is odd. I cannot have a symmetry like this, that will take away 3 from the picture. So there are 2 ways to do it. Either you can form a symmetry by saying 2 elements from here and 3 elements from here. That's one of the ways. All you can say is, I'll take a symmetry by taking 3 elements from the left and this. And this is very simple. If you want to do a symmetry, like I'll go ahead and do a symmetry like this, where I say, I'll have a bit more elements on the left and slightly lesser. So what is the total number then? It's like n1 plus n2 plus 1 by 2. Why? Because 2 plus 3 plus 1 is 6 by 2, that will give you 3. So I'll have 3 elements on the left and I'll try to make 3 elements. Will the formula for median change? Yes, it will obviously change. Let's look at this. In this case, you have 1, 2, 3. So you have 1, 2, 3. So you have like 2 and 1, 3 from the left, and you have 4 and 4 from the right. So what's your median? The median is 3. The median is 3. In this case, the formula will have median as max of L1, L2. That's your median. Very simple. You just have to decide that your symmetry will be either you can take 3 elements or 2. That's your choice. If you decide to take 2 and 3 on that side, then the formula will become for median min of R1, R2. Then you take from the right. I will go with this. Why do I go with this? Because this formula will be valid for everyone. Because even if I have 10 elements and I do 10 plus 1 by 2, that still says me the symmetry I need 5. Even if I have 5 elements and I do this, it still says 3. So the formula is valid. So the formula will be how many will be on the left? N1 plus N2 plus 1 by 2 minus, this is the number of elements I need on the left. On left. That's it. This is what I'll work on. So even if it's 10, I need 5 elements on the left. Even if it is 5, I need 3 elements on the left. So it works for both of them flawlessly. And everything stays the same. So I'll be writing the code in the code editor directly this time, not on the iPad, because it might get a lot messier on the iPad. And the code editor, I'll be writing it on C++. From the notes, you can find the Java, Python, and JavaScript codes as well, and you can open them on the parallel. And one thing, I'm writing like simple while if else conditions, so you will be able to understand even if you don't know the language. So don't worry about that. So the first thing that we'll do, we'll take N1, that's array size. I'll take N2, right? That's the first thing we'll do. What is the next thing? I know one thing for sure. If N1 is greater than N2, I always want to perform the binary search in the small array. So maybe just again call this function so that it just swaps it. Because I want to make sure that A is always the smaller array. The first array is always the smaller array. Perfect. The next thing I'll do is I'll say low to be 0 and high to be N1 because that is what I'm looking for. After this, I'll go ahead and do the same condition that we have been doing throughout. After this, I'll take the mid one because the middle in the first array to be low plus high by 2. After this, I'll figure out the mid 2. What will be mid 2? The number of elements that I require on the left. How many do I require on the left? You just now saw we figured out the formula. N1 plus N2 plus 1 by 2. That's how much we require. So on the left, whatever is required minus mid 1 is what it will be. Now I need to assign L1 and L2. So maybe initially you can do is you can keep them as intervene just in case they are not there, and L2 as intervene just in case, and R2 and R1, and you can keep them as intmax in case they are not there. So we have given default values to L1, L2, R1 and R2, but now we need to assign them. Let's come back to the iPad. So mid 1 is something which is pointing to R1, and mid 2 is something which is pointing to R2. And one place before mid 1 is L1, and one place before mid 2 is L2. But you need to be sure about checking their places as well. Imagine you're taking this array, like just in case, and then like you want to pick 6 elements from the array one. So mid one is going to be 6, which is a hypothetical index in this case, which is a hypothetical index in this case. So that index might not exist. So always make sure if mid one is lesser than n1, then only you will go ahead and say r1 will be taken from array of 1 and mid 1. If mid 2 is lesser than n2, then only r2 will be taken from b of mid 2, because otherwise that index doesn't exist. If mid 1 minus 0 is, sorry, minus 1 is greater than equal to 0, then L1 will be taken by mid 1 minus 1, otherwise they do not exist. If mid 2 minus 1 greater than 0, then L2 will be taken from B of mid 2 minus 1. That's it. Once you have done this, when can I say that they are technically a possible solution? If L1 is smaller than R2 and L2 is smaller than R1, that is what I'll write. If L1 is smaller than equal to, very important, R2 and L2 is smaller than equal to, again L2 smaller than equal to R1, then this is possible. And this is possible. I just need to check if the total number. So what you can do is maybe you can just write n equal to n1 plus n2. So if n is odd, in that case the answer will be max of L1 comma L2. It's very obvious. Else the answer will be, again you have to do a lot of typecasting. Max of L1 plus L2 plus min of R1 comma R2. You typecast it into double, and after that you do a 2.0. That's it. Else, if, what are the conditions for high? L1 greater than R2. L1 greater than R2. In that case, high will go as mid minus 1. Else, low will go as mid plus 1. And you can just give a dummy 0, just because it has a double return type, so you have to put dummy return over here. But ideally, in all the cases, it will be ending over here. So I'll quickly go and run this and see if it is running fine. So make sure that this is mid 1, and just make sure that the typecasting is done correctly. I'll go ahead and run this and see if it is running fine. I hope it does. It does. Let's quickly submit this and see if it is running. It will. So what will be the time complexity? We are doing a binary search on somewhere a size of n1, where we're making sure that the n1 is the smaller size. So according to the problem, minimum of logarithmic of n on it. So whatever is minimum will be our time complexity. Are we using any extra space? No, the extra space is big often. We're not using any extra space, and this will be the most optimal solution. So I hope you've understood the brute, the better, the optimal, the entire thought process, the intuition, and everything. Just in case you have, I have a lot of energy still now. Like this video took me I think around 2 hours, because I was spending a lot of time making sure that everyone who watches this video understands everything. So in case you're still watching, please make sure you like this video, and if you haven't checked out our Strivers A to Z DSA course, there's a link in the description. Make sure you check it out. And if you haven't followed me on Twitter, Instagram, LinkedIn, all the profile links will be in the description. With this, I'll be wrapping up this video. Let's read some of the video.
What a question, bro.
You don't have anything playing.
Size, because you're doing a binary search on a 6 array. So will it be better if I do a binary search on the smaller array? Because
Bro, what a question, bro. Okay, I think that's all for today. आज की वही प्रॉब्लम बहुत ही ज़्यादा हाई लेवल था. चलो, बाय।